Welcome to a slow, beginner-friendly lesson on the integer type, made for absolute beginners. This lesson only explains what an int is. The next lesson shows everyday use. We stop before operators and mixing types. The word int is short for integer, a word from mathematics that simply means a whole number. 0 is an integer. 42 is an integer. -7 is an integer. What disqualifies a number from being an integer is a fractional part. 3.14 is not an integer, because of the 0.14. So the rule is simple. If a number has no fractional part, it is an integer, and in Python we call that type int. Integer means whole. The defining feature of an int is the absence of a fractional part. An int is whole, all the way through. The moment you write a decimal point, even if the fraction is 0, Python treats the number as a float, not an int. 5 is an int. 5.0 is a float. They represent the same quantity, but they have different types. This will matter a great deal later. For now, hold the simple rule. No dot means int. A dot means float. No dot means int. Counting begins at 0 in programming, and 0 is a perfectly good int. It is not nothing, none is nothing. 0 is the count of an empty shelf, the age of a newborn, the score at the start of a game. 0 is a whole number, exact and proud. Remember it, because you will write it more often than any other integer. 0 is a real int. Here are some ints in the wild. Age 34. Count 0. Temperature -7. Population 1300. Notice what they have in common. Every one is written as digits, with an optional minus sign, and no decimal point anywhere. These are all whole numbers, so they are all ints. Python stores each one exactly as written, with no rounding, no approximation, because whole numbers are clean and exact by nature. Clean digits, no dots. Ints come in 3 flavors. Positive whole numbers, like 42 or 1300. 0 itself. And negative whole numbers, like -7 or -100. All 3 are ints, all 3 are treated the same way. The minus sign does not change the type, it only flips the sign of the value. So a bank balance of -50 is just as much an int as a balance of +50. Whole numbers, in any direction, are all ints. All 3 flavors are ints. A common point of confusion worth clearing now. 0 is an int. It is a whole number, a real value, the count of nothing. It is not the same as none. None means there is no value at all, the question has no answer yet. 0 means the answer is 0, which is a perfectly good answer. An empty shopping basket has 0 items. That is an int. A basket you have not even looked at yet has none. That is not. The difference matters. 0 is not none. Here is something that surprises newcomers. In programming, we usually start counting at 0, not 1. The first item in a list is item 0. The first second of a timer is second 0. It feels odd for about a week, and then it becomes completely natural. 0 is an int, and it is the natural starting point for counting in code. You do not have to love it today. Just know it is coming, and that 0 is a real, useful int, not a gap. Odd for a week, then natural. Ints scale from the tiniest count to numbers larger than you will ever need. The number of steps you walk today, the population of a city, the stars in a galaxy, all whole numbers, all ints. Python handles enormous integers without breaking a sweat. Whatever you need to count, however large, there is an int ready to hold it, exactly. From tiny counts to galaxies. So when do you reach for an int? The simple test is this. If the value is naturally whole, it should be an int. Counts, like 3 apples or 7 errors. Ages, like 34 years. Quantities, like 12 seats. Anything where a fractional part would make no sense, that is a job for an int. If half a value is meaningless, like half a person or half a click, then the value is naturally whole, and an int is the right type for it. The simple test. Here are values that are naturally whole. 3 apples. 34 years of age. 12 seats. 0 errors. Each of these is a count, and counts are whole by nature. You would never say you have 3.5 children, or 12.1 seats. The fractional part is meaningless, so these are all ints. Whenever you meet a value like this, one where fractions make no sense, reach for int. It is the honest type for honest whole amounts. The honest type for whole amounts. So how does int differ from float? An int is whole, with no fractional part. A float can have a fractional part, written with a decimal point. The quantity might be the same, 5 and 5.0 are equal as amounts, but the type is different. 5 is an int. 5.0 is a float. The dot is the deciding clue. No dot, int. Dot, float. Later you will learn how Python combines them, but the basic distinction is simply, is there a fractional part or not? The dot decides. A clean count is a beautiful thing. 3 users, 7 retries, 0 failures. Whole numbers carry certainty, because there is no fuzzy fraction to argue about. Ints are the type of certainty. When a value is whole, you know exactly what it is, down to the last unit, with no approximation and no doubt. The type of certainty, here is the dot doing its decisive work. 5, written plainly, is an int. 5.0, with a decimal point, is a float. They represent the exact same quantity, but type confirms they are different types. This is not a quibble. It matters when you do arithmetic, and it matters when you compare values. So train your eye to spot the dot. The dot is the signal that turns a whole number into a fractional one, and an int into a float. Train your eye on the dot. One of the kindest features of ints is that they are exact. The int 34 is stored as exactly 34, with no rounding, no approximation, no tiny error creeping in. Whole numbers are clean by nature, and Python honors that. 34 stays 34, forever, no matter how many calculations you do. This is not true of floats, which we will see later can carry tiny errors. With ints, what you write is exactly what you get. What you write is what you get. Because ints are whole, they never round. 34 plus 1 is exactly 35, always, with no surprises. And this exactness holds even for very large integers. Python can handle integers with hundreds of digits, and every single digit stays exact. There is no fuzz, no drift, no mysterious .001 error. Whole numbers are the honest, clean corner of arithmetic, and ints are how Python keeps them that way. You can trust an int completely. Trust an int completely. Here is exactness in action. 7 plus 3 is 10, an int, perfectly exact. 7 minus 3 is 4, also exact. But look at the float example below. 0.1 plus 0.2 gives a long, ugly number, not the clean 0.3 you would expect. That tiny drift is the cost of fractional storage. Ints do not have this problem. Whole number arithmetic is always clean. This is one big reason we reach for ints whenever a value is naturally whole. Whole arithmetic never drifts. Picture a table with row after row of data. Each row is one whole record, counted cleanly as 1, 2, 3. Ints are the type that counts rows. They turn messy reality into clean tallies you can trust, because every count is whole, exact, and free of fractions. That is why so much of data work rests, quietly, on integers. Row after clean row. Here is a lovely trick for large integers. You can put underscores between groups of digits, and Python simply ignores them. 1,300,000 can be written as 1 underscore 300 underscore 000. To Python it is exactly the same number, but to your eye it is instantly readable. Use underscores the way you would use commas, to group digits in threes from the right. It costs nothing, and it saves you from miscounting zeros. Commas for your eye, nothing for Python. Compare these two lines. Above, a billion written as a 1 followed by 9 zeros. You have to stop and count the zeros to be sure. Below, the same number with underscores every 3 digits. 1 billion, instantly. The value is identical, the type is identical, only the readability changes. This is a small habit with a big payoff. Anytime you write an integer with more than 4 or 5 digits, reach for the underscore. Your future self, reading this line, will thank you. Small habit, big payoff. Step back and feel what ints are for. They are the type of counting. Anything you count, apples, people, clicks, errors, is naturally whole, and that is exactly what an int is built to hold. Whenever a fractional part would make no sense, whenever the value is a tally or a count or an age, reach for int. Whole, exact, and clean. Those 3 words are the heart of the type. Hold them, and you already know when an int is the right choice. Whole, exact, clean. A quick practice to build the reflex. 4 values. Before reading on, predict each type. A is 8, an int. B is -3, also an int, the minus does not change the type. C is 0, an int, 0 is whole. D is 4.0, and here is the trap, the dot makes it a float, not an int. If you caught that last one, you have understood the lesson. The dot is the deciding clue, every single time. The dot is the clue. Int is the very first type you have studied in depth, and that makes it a foundation brick. Whole, exact, and clean, it is the type you will reach for whenever you count anything. Place this brick well. The other types will stack on top of it, and the clearer your feel for int, the easier every later type will be to learn. The first foundation brick. Let us gather the whole lesson. Int, written int, means integer, a whole number. 0, 42, -7, all ints. The defining rule is the absence of a fractional part, And the practical clue is the absence of a decimal point. Ints are stored exactly, with no rounding, ever, even for very large numbers. And underscores let you group digits in big integers for easy reading. If you hold those 4 ideas, you understand what an int is. 4 ideas, held together. The takeaway, in one breath. An int is a whole number, the type you reach for whenever you are counting something. It is exact, clean, and free of fractions. Use underscores to keep big integers readable, and trust that what you write is exactly what you get. In the next lesson, we move from what an int is to what you can do with 1, addition, subtraction, and the rest. Whole number arithmetic, coming up next. Take a breath. Another brick, placed. Another brick, placed. Thanks for watching. Next, using ints.